Assalamualaikum warahmatullahi wabarakatuh. In this video, I will proceed with the 2.5 composite function. So what is the composite function? So let's say a function that is written inside with another function. So that is the composite function. So we denote as a FOG, or we can also rewrite as F square bracket GX. So sometimes we can also write down as F gx. So this is also referred to the composite function, and I have mentioned in the composite function FOG or FGX, it is not equivalent to the product between two function FG. So this is referred to the product between two function, and this is referred to the composite function. How to find out the domain for the composite function? First, we have to look at to the domain of the final expression or the domain of that composite function, and that domain must intersect with the domain of the inner function. So if it is F composite G, so the inner function is G. If it is G composite F, the inner function is F. So let's look at today's exercise 2. So there are 6 questions altogether. So I will just discuss few questions here. The rest you can try out by your own later. So let's look at to the first exercise here from the question number 3. F composite G given as x plus 3 over with the x minus 1, and you are given the inner function, which is the function of G, which is equivalent to x plus 3. So what we have to do here in order to get the inner function, so first we need to write down the composite function. F gx is given as x plus 3 over with the x minus 1. So we can rewrite the function of G here, which is the inner function, which is x plus 3. So this one is also equivalent to x plus 3 over with the x minus 1. So since this is already the function, so in order for you to get the outer function, in this case is the function of f, so we have to let, this is one of the ways, so we can let the y is equivalent to x plus 3. So when we put x as a subject, we will have y minus 3, then whatever terms of x that we get inside the composite function, we can, so now it will become fy is equivalent to y minus 3 plus 3 over with y minus 3 minus 1. So we will get the terms here as y over with the y minus 4. So that is fy. So we have to change back in terms of fx. Therefore, the fx is equivalent to x over with the x minus 4. So this is the final answer, or this is the outer function, the function of f. Then let's look at to the question number 4 here. You are given again the composite function, and you do have the outer function. Then we need to find out the inner function. Just now we do have the inner function, we need to get the outer function. So now we have the composite and also the outer function, so we need to determine the inner function. So this is the way how to find out the inner function. So we have here f gx given is equivalent to 4x squared minus 9, and we can substitute the x with the gx inside the function of f. So 2 of the gx minus 1 is equivalent to 4x squared minus 9. So we have here gx, 2gx is equals to 4x squared and then minus 8. Therefore, the function g is equivalent to 4x squared minus 8 and then divided by 2. So we have to write down the answer in the simplest form. We have here 2x squared minus 4. So this is the final answer. So now when we try to find out the domain of this function, So what is the domain of the final expression? So let's go back to the previous question number 3. So in order for you to determine the domain of the F composite G, so we have to look at to the domain of the final expression first. So the final expression, the domain here is equivalent to x cannot be 1. So on the numerator, x can be any values. So since it is in terms of rational, so our concern is the values in the denominator. So what makes the values of x minus 1 become 0? So when your x is equivalent to 1. Therefore, the domain of the final expression here is from negative infinity until 1, union 1 until infinity. And then we have to make sure this domain must intersect with the inner function. So the inner function just now is a linear function. So since a linear function, the domain of the linear function is a all real number, so when you try to find out the intersection between the domain of the final expression, therefore the final domain is just the domain of the F composite G, or you can just write down domain. So the domain is from negative infinity until 1, union 1 until infinity. Now let's look at to the how to find out domain for the question number 4. So given the composite function here fx squared minus 9, so the domain of the final expression here is from negative infinity until infinity, and we have to make sure it must be intersect with the domain of the inner function. So our inner function is quadratic, therefore the domain is also from negative infinity until infinity. Therefore, the final domain is from negative infinity until infinity. Let's look at to this question. If given f is square root of x, gx square root of 2 minus x, so we need to find out g composite f and also g composite g and its domain. So the first one, we have to find out the function g composite of f, and then it is equivalent to the function of g, and our f is square root of x. So we need to substitute square root of x inside the function of g. So we have here 2 minus square root of x. So this is g composite f. And how to find out the domain? First, we have to determine domain for this final expression. And this final expression is 2 minus square root of x square root. So the terms inside the square root must be positive. Therefore, 2 minus square root of x must be greater than equivalent to 0. Negative square root of x greater than equivalent to negative 2. And we can make both sides become positive. Then you have to reverse the inequality sign. So we have here positive square root of x is less than equivalent to positive 2. And we need to square both sides in order to get x. Therefore, x is less than equivalent to 4. So this domain of the final expression must intersect with the domain of the inner function. So what is the domain of the function f? X must be bigger than equivalent to 0. Then what we need to do here is we have to combine these two domains. So by using line graph. So we have here 0, 4, and then the domain for the final expression is less than equivalent to 4, and this one should be dot. And for the inner function, it must be greater than equivalent to 0. So this line intersect starting from the values of 0 until the values of 4. Therefore, the final domain of the composite G composite F is close bracket 0 until 4. Now let's look at to the part B. Find out G composite G and its domain. So the composite function GG. So for the part B, we have G composite with the G. So we have here equivalent to G. Our Gx is square root of 2 minus x. And then the function of G, we have square root of 2 minus square root of 2 minus x. So this is the composite function. Then our domain, first we have to determine domain for the final expression. So 2 minus square root of 2 minus x must be always bigger than equivalent to 0. Then negative 2 minus x bigger than equivalent to negative 2. And it's better for you to put these terms become positive because x, we have x here. So square root of 2 minus x, so reverse the inequality notation, less than equivalent to positive 2. The next one, we have to solve by square both sides. So you will get here 2 minus x is less than equivalent to 4. Negative x less than equivalent to 2. And we want to make this one become positive. X will be greater than equivalent to negative 2. So this is our domain of the final expression. Then the next one, this domain, which is x greater than equivalent to negative 2, it must intersect with the domain of g. So what is the domain of g? So domain of the function g, which is 2 minus x, must be bigger than equivalent to 0, negative x bigger than equivalent to negative 2, and we have to make again this term become positive. Therefore x is less than equivalent to, this one also you multiply with the negative, so you will get positive 2. So what we have to do here is we have to draw a line graph to determine the intersection values. So we have negative 2 and 2, and for the final expression, the domain, so this is our first domain, comes from the final expression greater than equivalent to negative 2. This is our second domain, comes from the inner function, and it must be less than equivalent to 2. So the line intersects starting from the values of negative 2 until 2. Therefore we can write down here, so the domain is from close bracket negative 2 until 2. Okay, now let's look at to the question number 5. We need to determine f composite g and its domain. So what is the f composite g? So we have here f, g is 3 over x, and we have to substitute x as a 3 over x inside the function f. So we have here 3 over x over 3 over x plus 2. So you have to solve everything here. So we will get 3 over x. So over with 3 plus 2x over x. Then we can move these terms in the denominator to the other side. Therefore 3 over x will times with the x over 3 plus 2x. So we can simplify by cancel out x. At the end, the final answer will be 3 over 3 plus 2x. So this is the domain, this is the composite function. And then we need to find out the domain. So first step, we have to look at or determine the domain of the final expression. So since it is in terms of rational function, therefore our concern is the terms in the denominator. What makes denominator 0 is the restriction values of x. Therefore 3 plus 2x cannot be 0. 2x cannot be negative 3. Therefore x cannot be negative 3 over 2. So that is domain for the final expression, and that domain must intersect with the domain of the inner function. In this case, our inner function is 3 over x, so x cannot be 0. Otherwise this function will be undefined. So we have here these two domain must intersect. So when you have this kind of domain, for you to combine, you don't need the line graph because we do have both cannot be 0 and cannot be negative 2. So otherwise, if you want to still sketch your line graph, so it will looks like this. So we have negative 3 over 2 and the values of 0. So for the first domain here, which is referred to the x cannot be negative 3 over 2. So this is how the graph looks like. All real number except negative 3 over 2. And for the second domain, which is domain of the inner function, x can be all real number except 0. Therefore, the line redundant all except on the values of 0 and negative 3 over 2. Therefore, the domain is negative infinity until negative 3 over 2 open union negative 3 over 2 until 0 open union 0 until infinity. So this is the final domain. Okay, I think that's all. You can try out the rest of the question, then you can check the answer from the answer given in my website. Okay, thank you.